Yes.
Welcome all. In this session, we'll be focusing on solving the previous term questions of Java and term. To help reinforce your understanding of the Java concepts, the goal is to provide a comprehensive review of key topics and address any questions or doubts that you may have regarding the concepts. So, you can expect in-depth coverage of Java topics through practice questions, previous term questions, interactive discussions and problem solving, and opportunities to understand concepts from the point of view of those questions. So let us get started now. We have Dipanshu with us, who is currently also the teaching assistant for Java subject. The session is brought to you by Gearhouse, which is the best among houses. So Dipanshu, you can take over from here.
Okay, thank you so much. So I'll start sharing my screen. Just let me know if it's visible.
Sure.
Yes, I'm sharing now.
Yes, your screen is visible.
Okay, guys. So I'll start now, and if you feel any difficulty, you can just unmute yourself and ask the doubt. Okay, so here we are doing the previous term question for it's, I guess, set 24 term. Yes. So here is the very first question, which is based on the threads. So if we check the question, here we have an abstract class
I have
operation
one
that
question.
implements the runnable interface. Yes.
Yes, the question is usually how many questions are there in the Java, uh, sorry, end term examination
In end-term exams, there would be around 24, 25 questions.
in Java? Okay.
Yes.
Is there any topic wise division? Like how much can we expect from which weeks?
Exact division I can't tell because most of the weeks are interconnected with each other. But yeah, you can expect around 60, around 50% from the first 8 weeks and maybe the rest of the 50% from the next 4 weeks.
Okay, thank you. Please continue with the questions.
Yeah. So the very first question that we have here starts with an abstract class operation that implements the runnable interface. So we know this about the runnable interface that it has an abstract method run, and every extending or every class that implements this runnable interface must override the run method. So here first we have a class variable total, which is initialized as 10. Now there are two classes, operation 1 and operation 2, which extends this operation class, and both classes have their own implementation of this run method. So in operation 1, it checks if the total is not equal to 8, it will decrement the value of total by 3. And the second one checks if the total is not equal to 7, then it will decrement the value of total by 2. So till here, it's simple, right? Now we come to the main method. Here we have defined two instances of operation 1 and operation 2 class, and then we have created threads out. Now we are starting both our threads, and finally in the main thread we are printing the value of this total attribute from our operation class. Okay, so what can we expect? So I'll just try to draw some figure. Here we have our main thread. In our main thread, first we did this t1 dot start. Okay, so t1 dot start will create some another thread. Maybe let's call it t1 thread. And here we'll be having t2 dot start. That would create one more thread. Okay, so since all of you have Java here, can I ask a question? Guys, can I ask a question? Okay, am I audible?
You are audible.
Okay, so no one wants to hear the question. No issues. I'll just ask it. And if you know the answers, then you can just unmute and answer it. So the question here is, what's the difference between the run method and the start method? What's the difference between these two methods? Anyone? Okay. If I just say T1 dot start, so like any other method, it will go and search for the run method here and it will execute the run method. Right now I'm a little busy. It's noisy around, no issues. So we were saying that run method, it's just like any other method. If you call it, it will get executed in your main thread itself. Okay, that means if you say T1 dot run, so these three lines or two lines will get executed, and then maybe you'll move to the next line here, which says that T2 dot start or maybe T2 dot run. Okay. So in run method, the code inside, when you invoke the run method, the code inside your run method gets executed in your main thread itself. But when you invoke the start method, the code inside your run method will get executed, but the code will be executed in a different thread. So it will create a new thread and there the code will get executed. So when you said uh, thread T1 is equal to new thread and then you passed OP1, so it created a new thread object for it. And when you say start, so basically the code inside it starts executing. Okay, like it's a very naive way of saying it, but as we look for the stages of a thread, we'll get more idea about it. But for now, we can just think of it as when we invoke the start method, the content of the run method starts getting executed in a parallel thread. Okay, same will happen with T2 dot start. So T2 we made out of this operation 2 instance. So that means the run method of your operation 2 will get executed in another thread. So here the run method from your operation 2 will get uh, executed.
Yes,
So
I
let's,
also asked Meta AI about the difference between run and start. It says that in Java, run and start are two methods used in multi-threading. While the run method contains the code that is executed by a thread, the start method is used to start the execution of a thread. Run method is the entry point for the thread's execution, whereas when you call start, it creates a new thread and calls the run method in that new thread. The start method returns immediately, allowing the calling thread to continue executing. Whereas uh, when you run call directly, it executes the code in the same thread, blocking the calling thread. Is this correct?
yes, like I was not able to hear your entire answer because I just lost my connection in between. But it's like if you call the run method directly, the code gets executed in the same thread, and then you move to the next line. But when you call the start method, so the content inside your run method gets executed in a different thread. So your main thread uh, is executing its other line, while the content of the run method it's getting executed in some other thread.
Okay, that is clear for me. I hope it is clear for others as well. Okay, Riddhi asks, can you please give an overview of what is multi-threading?
Okay, multi-threading. Okay, so just suppose I have this laptop in front of me and I'm writing here in one of the app journal, and in the background the meeting is going on. So you see, my computer is able to perform a lot of operations at the same time. But how the computer is doing it? And that introduces us with the notion of this concurrent programming or maybe the parallel program. Though both are not same, but often they are considered same by people, but it's a misconception. So we'll see the difference between the parallel computing and this concurrent programming. So what happens? Let's suppose I want to perform multiple tasks at the same time. So how can I perform the tasks? let's suppose I am just having a single core processor. That is, there is only one core in my CPU that can process all the tasks. And there are hundreds of tasks that the CPU needs to process. So how it will do it? So there is something called scheduler. So what scheduler will do is my CPU will quickly switch between the tasks. Okay, so there are different tasks. Let's say these many tasks are there, and my CPU will quickly switch between the tasks. So let's say it executed this, then this, maybe it came back to this again, and then went back to this, then this, then this. So it executes them uh, in a way that it quickly switches between the tasks that creates an illusion of parallel computing. Okay, for example, when we see the videos, right? So the video is nothing, just a thousand frames of video and thousands of frames of audio. So
I think there's some connection issue from Dipanshu's side. Please wait for a few minutes.
am I not properly audible?
Now you're properly audible.
Okay, so just could you just tell me that where we left? What was the last thing that we discussed? Hello.
Yes, actually, we could not really make out of the last part.
Okay. We
You
were
talked
talking
about the
about
videos.
this. Yeah, so in videos, what happens is there are thousands of frames, and because we quickly go through all the frames, so it creates an illusion that it's just a smooth single video. There are no different frames, right? So similarly, what our scheduler does is it quickly switches between the tasks. So it looks like that all the tasks are being executed parallelly. So this is what we call concurrent programming. Okay. Concurrent programming is I'm quickly switching between different threads. So each thread is performing one of the tasks at a time. Okay. And I'm quickly switching between those threads so that it creates an illusion of parallel program. Okay, this is what concurrent programming for us. And that is why we need different threads, because having multiple threads means I'm executing multiple tasks at a time. In each thread, I'm executing one of the tasks. Okay. And this process of continuously switching between the threads, it's what we call time slicing. Okay, that means I'm allotting some time to each thread. Okay. So are there any questions or is it clear? Hello.
It is clear to me.
Okay. So here we come to the run method. So parallelly, this run will get executed. So what this run is doing? This run is doing, uh, if total is not equal to 8 maybe, then it is decrementing the value of total by 3. Let's check it whether it's same or not. Yes. And the second run, it's checking if the total is not equal to 7, then you decrement your total by 2. Okay. So now let's try to see that what are the possible scenarios in this question. So if I try to print the value of total, what do you think? What should be the output? What should be the output? Can you guess any output?
It
Anyone?
will stay 10 only, I guess.
Yeah, okay. Could you please repeat yourself?
It would stay 10 only, I guess.
Okay, one of the possible output would be 10. And why do you think it would remain 10?
Because even though it is going to run in first thread and second thread, it is not satisfying the if condition. That's why.
Okay, let's see. For example, I started with total equal to 10. I maybe go to this thread now, and here it checks whether t is not equal to 8 is correct or not. So what do you think? If I put 10 in this scenario, that is 10 not equal to 8, what it should give me? True or false?
Oh, sir, yes, it's true.
Okay, it will give me true. Then what will happen? If it gives me true, I'm decrementing the value of t by 3. So t becomes 10 minus 3, that is 7. Correct?
Yes,
And after this, let's say I go to this thread. So as of now, the value of t is equal to 7. So I come here and I check whether 7 not equal to 7. What do you think? What should be the output of this? Like, will it give me true or false?
this would be false.
Hmm?
False.
False. That means I'll not move to this line. And after that, if I try to print the value of total, that should be 7 for me. Correct?
Yes.
So one of the possible output in this case is 7. So I hope it is clear. But is 7 the only output? Because we are having three different threads. Okay, and all three different threads are being executed at the same time. That means other outputs are also possible. Okay, so we took one of the flow where we were starting from here, then we went to this thread, and then we went to this thread, and then we printed this. But what happens, let's say, now I'm going to use the red color here. What if I start from here, then I maybe move to go to this thread, and then I go to this thread, and then I try to print the value of total, correct? It is also one of the possibility, right?
Sir, isn't
Yes,
it by
no.
the flow of the program?
See, what T1 dot start is doing, T1 dot start is creating one thread here, T1, and T2 dot start is starting the another thread here, T2. But these threads are now being
I think again there's some issue with his connection. Let him come back. He'll come back in a minute.
hello, am I audible?
Yes, you are audible.
Yeah, sorry for that. Okay. So we were talking about that flow. One possible flow was what we colored in green. That is, you start from the total and then maybe you try execute this thread and then you move to this thread and then here you print the value of total. There could be other possibility also because everything is being processed parallelly. So in the background, let's say this gets executed first and
Our
then you
screen is
move
not visible
and
to
then
us.
finally you try to print the value of total. Uh,
Like,
I hope it's
yes, thank
visible
you.
now.
Yes, visible.
Yes, so there could be a second possibility where we, let's say, start with the total and then we move to this thread over here and then we go to this thread and then finally we print the value of total. So this is the second possible flow of execution, right? So if we go through this flow, what would be the value of total? So let's say total was initially 10, then we came here. So we check whether 10 is equal, not equal to 7 is true or not. So 10 not equal to 7. It will give me true, correct? So I'm going to decrement the value of t by 2 and then t will become 10 minus 2, that is 8. Okay, with t equal to 8, now I'm going to go here and I'm going to check this condition. If 8 not equal to 8, which is false, that means I'll not execute this line and then I can print the value of total and here the value of total would be 8. That is the second possibility. Is it fine?
Sir, but how do we decide the flow? Isn't it by
Please go on.
Your voice is breaking a lot.
Okay, so sorry for the frequent connection losses. Uh, I'm back again. Yes. So here, what we were saying that whenever you have multi-threads, multiple threads running in the background, so you should think about all the possible scenarios. And now we are going to discuss one very interesting scenario. That is when you are starting with total equal to 10, and maybe you start entered this thread and you check for this condition whether t is equal to 8 or not. So since 10 is not equal to 8, so this condition will get satisfied and you should move to the next line. But let's suppose your scheduler decides that before you execute this line, you go and execute this line from the other thread, your T2 thread. That is to check whether t is not equal to 7. So this was the first line in the sequence that we executed. Then maybe we went here, we started another thread also. And here in this thread, we executed this line where we are checking whether 10 is equal to 8 or not. And then if this condition will get satisfied, we'll move to the next line. But our scheduler decides, yes, you are anyways going to move to the next line because you now passed this condition. But your scheduler decides, let's execute this line first. So the fifth line in the sequence is going to be this, where you are checking whether t is not equal to 7 is correct or not. So again, as of now, you have not updated the value for your t. So your t is still 10. So you'll check whether 10 is not equal to 7 is correct or not. Yes, it is correct. So it will also allow you to move to the next line. So now you have two possibilities. Maybe this could be your 6 or this could be your 7, or this could be your 6 and this could be your 7. But in any case, you're decrementing first by 2 or then by 3, or maybe first by 3 and then by 2. But there would be a total decrement of 5 in your 10, and then maybe you can come here and print the value of your total. So eventually you will realize that from your 10, you have decremented a total of 5. So 10 minus 5 is 5. So this is also one of the possible outputs that you can get. Okay, so is it clear, guys?
Yes, this is clear for me. If anyone else has the doubts, please ask.
You are talking
Sir,
about
I did
concurrency,
not.
right?
Yes, this concurrency.
Sir, I did not get the 5 wala scenario.
Okay, the scenario when we got 5. So let's suppose you start with total equal to 10. You start both your threads. Here maybe you just focus on these numbers that we have over here, 1, 2, 3. After this line, here your scheduler decides to execute the line from here. That is to check whether 10 is not equal to 8. So this condition will get passed, correct? Because 10 not equal to 8 is a correct condition. So that would allow you to move to the next line. But before you move to the next line and make the update from here, maybe you can execute this line in your another thread. Okay, because when you have three threads parallelly running, it can happen that one line you're executing from one of the thread and the other line you're executing from maybe some other thread. So as of now, what we saw was in the green case and the red case, we were seeing that if you pass the condition, you first update the value and then you are moving to the other thread. But here we are seeing a very interesting scenario where we are maybe just executing one of the line, and before we execute the second line, we are going to execute some other line from a different thread. That is a line from here. So the flow of execution is like this. You start here, you go here, you go here, then you go here. But before you could have executed this line, you are going here and you are making this check. So you till now you have not updated the value of your t, and your value of t is still 10. So you will check this condition whether 10 is not equal to 7 is true or not, which is true. That means it will also allow you to move to the next line. So here you can either go to this line and decrement the value of t by 2, or again your scheduler may uh, switch to this statement and you can execute this statement from here. So either this could be your sixth or this could be your seventh line, or you can have this as your sixth line or this as your seventh line. But in any case, you are either first decrementing the value of t by 2 and then decrementing the value of your t by 3, or you are first decrementing the value of your t by 3 and then the total decrement is 5. So 10 minus 5 is what you are getting here. So I hope it is clear this time.
Yes, sir.
Okay,
Thank
and
you, sir.
even if it is not, so you can try to solve more questions on threads. Just try to go through the practice assignments from your week 10 and 11, and you'll get a better idea. Okay, so these three scenarios we have seen, but there is also one very interesting scenario. In this multi-threading, you'll always be having these interesting scenarios. So I'm going to color it as yellow. So let's suppose you start from here. Oh, it's not visible. So I should take maybe light green we have done. We can go with pink. So let's suppose first line that you execute is here. Maybe in the sequence, this comes next and this comes next. Okay. Now you will go to your threads. Maybe this could be your fourth line. This could be your fourth line. Correct. But what happens if this is your fourth line and later you do all these things? And later you do all these things. Because again, there are three parallel threads going on, and your scheduler may decide that it wants to execute this line first, and then maybe it wants to execute the lines from your thread. In this scenario, what would be the output? That is, your print statement is getting executed before you could have made any updates in the value of t. So what should be the value of total now? Or maybe what would be the output in this case? Anyone, guys? You're printing your total before updating the value of your total. So what should get printed?
10.
10.
Yes, 10, right? So if you'll wait for some time, you'll realize that finally the value of t will become either 7 or 8 or 5. But because there is a possibility that it gets printed before it will get updated by any of the thread. So yes, 10 could be a possible output. Okay, so these four outputs are possible. And
So,
when you execute multiple threads at a time, just a second, please. When you execute multiple threads at a time, so there is a possibility of getting such kind of ambiguous results. And this is what we call a race conditions. And this happens when we try to read or update the value of the shared variable in our multiple threads. Here in this line, we are reading the value of the shared variable, whether it's equal to some number or not. And in the next lines, we are trying to update the values of these shared variables. Yeah, please go on.
there can be, we can say that this may be the value. It is not that it will always be the value.
See,
It
output
can
is
be,
always going to be 7 or 8 or 5 or 10. Means the output is going to be one of these four outputs. But what would be there, you can't exactly predict that. It could be 8. So it's like you try to execute your code, you got 8 as the answer in your first try, and you try to execute it again before without making any change, and maybe you can get 5 as the answer.
I am asking this because they play with this condition, right? There might be may, there may be always, something like that.
Yeah, so the output is always going to be 7 or 8 or 5 or 10. Okay, so it's going to be one of these four, but you can't predict that which among these four. Is it fine?
Yes, sir.
Okay. Then maybe you can try to do some experiments with the same code. Try the run method over here. Okay. Right. Now we move to the next line. And that is the next question. Actually. Here you have this class beverage having some methods, a class coffee having some methods again, class latte having some methods again. So your coffee extends your beverage and your class latte extends your coffee. And here you are having your main method where in the first line you create an instance of latte, but you try to assign it to a variable of type coffee. So first question, is it permissible to do so? can a variable of type coffee can refer to an instance of type latte?
Yes, sir, because it says that latte extends coffee, so that means that parent will be coffee and latte can be the child.
Yeah. So if it comes in the ancestry, so it can be used to refer the instance of this subtype. Okay. Latte subtype of coffee. Now the next method here, next line here where we are invoking the ingredients method on drink. So what should you check? What your compiler will check? Your compiler will check whether the method ingredients is present in the reference type coffee or not. So ingredients should be present in your reference type coffee. So you go and check in the class coffee whether ingredients is present or not. Yes, it is present. Then the next line says whether the price method is present in your reference type coffee or not. So price
Yes.
is also present, and then it checks whether the maker method is present in coffee or not. So you check whether the maker method is here in coffee or not. No, it's not present here. Then you'll go and you'll check in the parent class of coffee, which is beverage. So here also the maker method is not present. And in the parent class of beverage, which could be object in this case, uh, the maker method is not present in your object class as well. So that would mean that the line 2 will throw the compilation error because this maker method is not present in your class coffee. Okay, so your compiler first checks whether the method is present in the reference type or not, and while executing, the method gets executed from the actual object type, which is latte in this case. Okay, but first your compiler makes sure whether the method is present or not, which is not in this case. So you will get a compilation error. Are there any questions? Hello? If there are no
No,
questions,
sir.
we can move to the next line. Okay. So in the next question, we have this file processing exception that extends our class exception. You have a constructor that takes a string and passes the string to the constructor of your parent class. So if you know the structure of these exceptions, so you'll know that the exception class has a parent class called throwable. And in your throwable class, there is this attribute called error message. Okay, so when you pass this message to the constructor of exception class, the exception class passes the same message to the same message or string to the constructor of its parent class, which is throwable. That uses the string to initialize the value for that uh, error message attribute. Okay, so even if you do not know about all these things, you can just know that it's just a way to initialize the message. Okay, there would be some attribute called mm, error message, and that would get initialized by the string that you pass over here. Any questions? Anyone? Okay, if there are no questions, we can check the next class, which is also an exception, and that is the same thing. And here we are having a class called file exception test. So in this class, we have our main method. Main method first tries to call this process file method. So we go to this process file method that can potentially throw this file processing exception. And here we see that it calls the validate file method. So now we go to the validate file method that throws this invalid file format exception having the message. Okay, so This validate file method throws an instance of this invalid file format exception having the message file format not supported. Maybe let's try to draw it. Your validate file method is going to throw this exception where you are having some message. Your message is what? File format not supported, maybe. Format not supported. And then you have what? This message you are throwing here. So validate file method throws this exception. This exception will get caught in this catch block. And what we are doing in the catch block is first we created an instance of file processing exception having this error message, error processing file. So same thing we are going to do with this guy also. It's a file processing exception. So I'm naming it as FPE. So it also has this message, maybe error processing the file. Error processing the file. Okay. Are there any questions still here? We created an instance of this invalid format exception. Invalid format exception. And then the exception got caught here. And here we are creating an instance of file processing exception with this error message, error processing the file. Guys, just let me know if there are any questions. Okay. Now what we do? We use this init cause method. So like we talked about this message attribute that there would be an attribute called error message in your throwable class. Similarly, there would be one more attribute in your exception class, which is your cause. So what this cause attribute stores? So this cause attributes can store any throwable. Okay, throwable means it could be an error, it could be an exception, but generally we'll be dealing with the exceptions only. So why do we need these cause and message? Just to provide more information regarding the exception. Okay, suppose you get any exception, so you should get more information with the exception, right? That why you got that exception. So the message will provide you some details regarding the exception, and then there would be this cause. So why you would use the cause? So suppose you want to tell that I got this exception A because of some exception B. Okay, this exception B caused this exception A. So how I can provide this information? So in my A, I can set the cause of A as B, that the cause of A is B. Same thing we are doing here. We created an instance of FPE, this file processing exception. And here we are saying this file processing exception was caused because of this E. What is this E? The E is the invalid file format exception that we just got. So which exception did we catch here? The exception which was thrown by this validate file method. That is the guy over here. So basically, we are setting the value of the cause as this invalid file format exception. Okay. So FPE has these two attributes. One attribute is message, which is this error processing the file, and the second attribute is cause, which is referring to this object over here. Object of class invalid file format exception, which also has an attribute called message having this string stored in it, format not supported, file format not supported. Are there any questions? Please say yes or no so that I know that I have not lost my
So
internet
actually,
connection.
in that question,
Mhm.
basically, I'm not getting actually this entire question itself. Means like, what is going on in this?
What's going on this question? In this question,
Oh,
so first we created these two custom exceptions. Are there
okay.
any doubts still here?
No, no problem. No problem, sir.
Okay, then we come to our main method. The main method first tries to call this process file method. Okay,
Hmm.
so you first have your main method. The main method is calling this process file method. Are there
Okay.
any questions?
No, till here no problem, but it throws a file processing exception that I know.
Yes. Yeah. So we go to the process file and we see the process file method is first calling the validate file method.
Hmm.
So you first go to validate file method.
A validate file is where it is defined.
It's here.
Okay. And it throws a invalid file format exception.
Okay. So here,
Hmm.
see, it does not mean that it will always, it's just mean it can potentially throw this exception. And where it is throwing, for that, we'll have to see the actual code inside the method. Okay. We'll have to see the actual implementation of the method. Okay. So that is why we saw the actual implementation of process file, which was calling this validate file. Now we will be checking the implementation of this valid file. So first question is, can you spot this structure of the stack? That is, you have your main method, which called this process file method, and that in turn called this validate
The
file method.
validate file method. Huh. Okay.
Okay. So now we'll start returning the values now. Okay. Or maybe we'll start uh, popping out these activation records from our stack. Okay, so it's like your factorial 5 called 4, then that called 3, that called 2, and so on. And
Hmm.
now once we are out from this validate file method, we'll start popping out these methods from our stack. So here we first see the implementation of validate file that throws this invalid format exception having the message file not supported. So it basically said it created this object. I'm going to circle it now. It created this object and it threw this object.
Hmm.
Okay, so it's an instance of class exception. So if it's an instance of class exception, you can throw that. Okay,
Okay.
throw that means it's like throwing an exception, which will be caught by any catch block.
Hmm.
So now, where will it go? It will go to the method that called the previous method, right? That is
Uh,
your process file. It
a
will go to
validate
your
file
process file.
exception, sir. Validate file exception will throw this because it is saying that
No, no,
throw
no.
new
There is
invalid
no
file format
validate
exception.
file exception. There is this validate file method.
Sorry.
Your validate file method threw this invalid file format exception. And now
Hmm.
the for that would be here in this line. Okay. So that means
Okay.
now you come out of this catch block because the moment you throw any exception in your try block, the exception gets caught in the catch block. So catching this exception in this catch block. Okay. So now in the
Okay.
catch block, you caught the exception and you're naming it as E. So from now onward, we are going to refer this exception as E.
E.
Okay.
Hmm.
Now, in the same block, what we did is we created a new instance of file processing exception having this error processing file as the message. And we are calling it FPE. Okay.
Hmm.
So let me just erase this for now. So this guy we created and we are calling it FPE.
Okay.
Okay.
Hmm.
Now in the next line, we say FPE dot init cause E. So in this line, we are saying cause of this FPE should now refer to E. What's your E? This guy. Okay. So whenever I say FPE, I'm talking about this guy. And whenever I say FPE dot get cause, I'll be talking about this guy
Okay.
because cause refers to this.
Hmm.
Is it clear?
Okay. So whenever I am calling this fpe.getCause, it is caused by the invalid file exception, right? That file
So
format exception.
yes. So think of it just as a getter method and a setter method. Okay. So init
Okay.
cause is a setter method. If I'm writing setter, it's init cause. So init cause is a setter method that would set the
Hmm.
value of this cause attribute as equal to E.
Okay.
Okay. And get
Hmm.
cause is just a getter method that would get you the value or maybe fetch you the value for
Original
this.
source of that error.
Okay. So it's
Hmm.
just like, because it's an object, so you can just create a pointer for the object. So it's just
Hmm.
referring to that object. And here when you say get cause, so get cause will also refer to the same object. Basically, it will fetch you the value, same object.
Okay. So, sir,
Okay, and it
if I
will
am
get you
not
the
wrong,
reference for the object.
sir,
Hmm.
if I'm not wrong, get cause would be like means like it will give the initial cause, means the real cause of the error.
No, no, no. See, when we say
Hmm.
init cause is just uh, a setter method to initialize the value of this cause. Okay, whether the cause happened because of that or not, whether it is the actual cause or not, doesn't matter. If I set init cause as E, so whenever I will use the get cause, it will refer E here. Let's say I
Okay.
create a different exception F, okay, which is completely unrelated to this question, but I pass F over here. Okay, so
Hmm.
whenever I say get cause, it will just give me F. So init cause is just like you are setting the value for this cause parameter as F, and get cause is like you are getting the value of this cause parameter. Okay,
So what do you
it's a
mean by
getter
value
method.
of get
It's
cause parameter?
value of this cause attribute. This get cause method will get you the value of this cause attribute.
And the
Okay,
cause
so it's
attribute
like
is
I have a,
pointing to.
yeah, for example, I have this person. So this person will be having some name. Okay, this name
Hmm.
attribute that points to some string. Correct. So
Yes.
I may say the string is hello. Okay, doesn't
Hmm.
matter whether I will have the methods as set name. I will have the methods like get name.
Okay.
So I can use the values of set name and get name to set the value for this name parameter, or get name to get the value of this name parameter.
Hmm.
Right. So
Hmm.
same, you can think of it as init name. Init name is doing the same thing. Just the name is not set name. The name is init name now.
Hmm.
Okay, so init name will set the value of this name parameter. Now it's up to me. If I want to set the name as hello, I can set, because I know there would be no person having this name hello. But doesn't
Hmm.
matter. I can set the value of name as hello. So same thing I'm saying over here as well. Whether the cause is this IFE or not, doesn't matter. Whatever E I'll pass over here. So when I call this get cause method, the same E I'll get. Okay, doesn't matter what the actual
Okay.
name of the person is. For your program, it will not matter, right? For your program, it only knows what instruction you have given to it. So if you pass maybe puppy over here, it will set the name of the guy as puppy. Name of the guy means this name parameter will now refer to puppy. And when you say get name, it will return you puppy. Doesn't
Okay.
matter whether it has some meaning or not. Same goes over here. There is this cause attribute. By using this init cause method, you can set a value for it. By using the get cause method, you can get the value for that parameter.
Okay.
Okay. Now, as a programmer, it is your responsibility to use it wisely. So in your cause, you should set the cause of the exception. That is why the exception was caused. But again, it completely depends on the programmer discipline, that whether the programmer wants to set it or not. Okay.
Okay.
Like here, it completely depends on the programmer discipline, whether the programmer gives the meaningful value to this name or not.
Hmm. Understood. So there is a cause param means like there is a cause variable. I can think of this like this. There is a cause variable which is pointing to some exception, and that's what we are getting when we use get cause.
This
And
cause,
to
yeah,
set,
this cause variable is of type throwable. So it can only what point to this throwable object. So throwable objects
hmm,
means either it could be an error or it could be an exception.
an exception.
Because we are dealing with the exceptions only in our course, so we'll be
Hmm.
only looking at exceptions.
Okay, and that is set by init cause. and then
Yes.
to retrieve it, we are using that cause. Okay, understood. So now understood.
Okay, so whenever I say FPE dot message, it will give me the message for this FPE object, which is error processing the file. And whenever I say FPE dot get cause dot get message, so that means FPE dot get cause is referring to this, and dot
Mhm.
get message means you get the message for this guy, which is file format not supported. Okay, so are there any questions?
No, sir.
Okay, so now your process file throws this FPE again, means now this is the exception that you have thrown. Okay, this is the instance that you have thrown. Uh, now again coming back to our stack structure, which is validate file first did its job, now process file did its job. Now you are coming to the main method where your process file threw this FPE exception. So now the FPE exception will be caught here and will now be given this name as E. Okay, so now here when we are saying E, what do we mean? When we are saying E, we mean this FPE guy, okay, which has some message, which has this cause, which refers to this invalid file format, which also has a message. Okay, so whenever now I say E, I'm referring to this guy over here. And when I say E dot get cause, so cause is referring to this, right? So I'm basically referring to this guy over here. So what will happen if I say E dot get message? It will give me this message from here. And when I say E dot get cause dot get message, that means you first to get to the cause and then get the message of the cause, which is this. Okay. So
Yes, sir.
here E dot get message should give you the message from here, which was maybe error processing the file in your first line. And in the second line, you should get this, the message from the cause, which is here, file format not supported. So first line of your output would be error processing the file, and the second line is going to be file format not supported. Are there any questions? Guys, anyone? Is it clear?
It's clear for me, sir, at least.
Okay, sure. So we'll move to the next question now. Just look at this question, okay? Yeah. So here we have our loan class. Am I audible?
Yes, sir.
Here we have our loan class where we have these three private instance variable, principal amount, the time, and the rate per annum. You have a constructor to initialize these variables. Then you have this calculate method where you have four assertion statements, and then you have your return statement here. A class assert state that would just create a new instance of class loan, and then it would invoke the calculate method on that particular object. So first thing, if you just say obj.calculate, so what do you think? You execute your code normally. What should happen in that case? So if you execute your code normally, we do not check the assertion statements in such cases. Okay, you just go to the calculate method and you just ignore all the assertion statements, and then only you return the value of p times t times r divided by 100. Correct? So the assertions will only be checked when you specifically write this hyphen EA. Okay, so this hyphen EA is just an acronym for enable assertions. Okay, so either you can write Java hyphen enable assertions and then name of mm, the file, which is assertion test, or maybe you can just write this abbreviation EA. Both could do the same thing. Okay, so when you do hyphen EA, now we need to check the assertion statements. So first we'll check whether the product of all three is greater than 0 or not. So 5000 times minus 1
Yes,
times
sir, it
negative
is.
quantity. Yeah, it's true. So if the assertion statement is true, you move to the next line. Okay, so assertion statement takes a condition. If the condition is true, you move to the next line. But if the condition is not true, that is, if it is false, then it throws the assertion error. Okay, so the first line is true, so you move to the next line. The second line is false. Second line is also true because 5000 is greater than 0. Third line is false because your time here is given as -1 and it says time should be greater than 0. So the third line will throw the assertion error. So if your third line will throw the assertion error, your program will stop abruptly and you will not move to the
Okay.
next line. So the
Sir, I have
first,
a question.
yes,
Uh,
yeah, please
if
go on.
uh, if some assertion starts in the main itself, like there is a statement for assert which is in main, and that becomes wrong, then we will say that that particular assert statement will be the first one to be cached, right? Because assertion starts from the main.
Uh, yes. Uh, so basically, if you want to know that what's the flow of your program or which assertion will be checked first, so you should go through the flow. That is, your code starts from the main method, and in the main method itself, if your code calls any object, then you go to the object. And sorry, if your code creates an object, so then you go to the constructor of that object and you check if there are any assertions over there. And maybe if it calls any method, so you go to the method and you check if any assertion statements are there. Okay, if the method returns its value, then you come to the main method again and you move to the next line. This is how you do it. Okay, so the code always
Mhm.
starts from the main method and then it will try to go and check out for different references comes in between. Okay.
Okay, sir.
Yes. So
Assert
assertion
three.
3 is the one. Yeah, assert 3 line is the one which will fail first. Now the next class says your locopilot implements clonable. Here you have a string, an array of integer. You use a constructor to initialize your name and trips attribute. Then you have your clone method defined where you are just returning super.clone. So super.clone basically means you're calling the clone method from the object class. And what it will do is it will just create a separate memory location, a separate instance for it. But the instance will be referred as an instance of class object, not of class locopilot. Why? Because whenever you use super.clone method, it just returns an object of class object. If you want an object of class locopilot, then you need to explicitly typecast it into locopilot. So even here in the question, we can see that though they have not specifically typecasted it to locopilot here, but if you check the execution of this clone method or the part where it's really using the clone method, we can see that it explicitly typecasts it into locopilot object. I hope it is clear for everyone. So you have
Yes,
defined
sir.
an array of integer, you have defined a locopilot object, and then you have created a clone of locopilot object. But again, while creating this clone, so when you do super.clone, only the primitive attributes get duplicated. The other attributes, which are non-primitive in nature, so you just create a duplicate reference for it. You do not duplicate their actual values. Okay, so here if I try to draw that what would be there in the memory, you can maybe try to put this entire thing in your Python tutor and you'll get a better picture of it. But here in this side, I'll be having my stack. On this side, there would be objects on the heap. Here I'll be having my locopilot 1, locopilot LP2, LP3 variables. So LP1, first an object will be created in my heap where it will be having a what? It will be having this name. So name is a string, right? So name parameter will refer to this guy Arjun over here. Arjun was the name, right? Arjun, yes. And then it would be having this trips attribute, which would refer to an array. Okay, and this array stores maybe 20, 25, and 30. Yes. And this LP1 refers to this object here. Are there any questions?
So if we clone an array, right? In
Mhm.
that in that case, it will just be a reference. It will not be a new memory location in itself, right?
We have not cloned an array. We have just cloned the object. So if you clone the
Mhm.
object, only the primitive data types.
So
Primitive
array
data
will not
types like
be.
yes, because array is not a primitive data type. Primitive data types are your integers, booleans, and your doubles, floats, etc. Okay, those will get duplicated. But if you have any non-primitive data type like a string or an array or maybe a user-defined object, so all those will not get duplicated. So you will just create a duplicate reference for it. So here, if you are cloning LP2, so it will create a duplicate reference like this, where you are having your name that still refers to Arjun, and you will be having your trips that still refers to this guy over here. And your LP2 refers to this new location. Okay, but let's suppose in your LP1 you would be having some primitive data type like x equal to 10. So that would get duplicated. Its value will get duplicated here, and you will get x equal to 10. So these are not at all interconnected with each other. Okay, but if there are these non-primitive data types, you're just duplicating the reference. You're not creating a new instance for it. Okay, so I hope it's clear. Moving on to the next line, we have this LP3 equal to LP1. So when you say LP3 equal to LP1, it basically means because LP1 is referring to this object, now LP3 should also refer to the same object. This is what you will say. This is what this line means, that both LP1 and LP3 should now refer to the same object. Both are same. Okay, so are there any questions still here?
No, sir.
Okay, so here we go to the next line where we see that LP1 dot name, we are just going to print then. Oh, before that, we'll be having these two lines where we are making some updates. So first update that we are doing is we are going to LP2, then LP2 dot trips, and here we are updating the value of the at the first index of this LP2 dot trips, and we are changing it to 40. So we go LP2 dot trips, that is this, and it says you go to the first index now. That is we go here, and now it says you change it to 40. So we change it to 40. Okay. Now in the next line, you say you go to LP3 and you change the name of LP3 to Vikram. So you go to LP3 dot name. LP3 dot name means this. And now it says you change it to Vikram. So now you basically cancel this line. That is now name does not refer to Arjun. Name rather refers to this guy. Uh, what name is there? Vikram. Okay, so this is how the picture will look. So the LP2 dot name is still referring to the Arjun because this Arjun had two references. Okay, so one of the reference has been deleted, and now this guy LP3 dot name refers to Vikram. But yeah, there is still one more reference for this Arjun which comes from LP2 dot name. Okay, are there any questions? No. So what would be the values here? LP1 dot name and mm, LP1 dot trips 1. So LP1 dot name is going to be Vikram now,
Vikram,
and LP1 dot trips 1 is going to be 40.
40.
LP2 dot name would be Arjun,
It's a
and
new
it
copy,
would be
right?
40 again.
40.
40 is what?
It is referencing, right? So everywhere the 40 will be there, right?
Yeah. Okay. And then LP3 dot trips 1 will be 40 again, and here you would be having your. So are there any questions on it? If no, then you can mark the correct option. This looks correct. Yes.
Sir, can you show the correct option? Yes, yes, right.
Okay, then you have your next question that comes from the serializability. So serializability is basically if you want to store your uh, data in your hard disks and all, so that needs to be converted into your bytecode. So if a class implements the serializable interface, only then it could be serialized. And serialized means the information gets converted into the bytecode. So it's like you have an information and the information is getting converted into the bytecode. So this is what we call serialization. And then you'll be having your bytecode and you'll be reading those bytecode and rewriting that to a and maybe retrieving your information back from it. So that would be your deserialization. So this is your serialization and deserialization. So while serializing an object, we may want some of the attributes of an object not to be serialized. Why? Because it may contain some sensitive information, for example, password. So you do not want to store your passwords maybe, or maybe it could contain some of the fields which are non-serializable in nature. For example, if it contains any information regarding the databases or it contains the database connection, so that in itself is non-serializable in nature. Or maybe your file handlers, those are also non-serializable. So how would you mark those fields that these fields need not to be serialized when you are converting my data into the bytecode? So for that, we have this keyword called transient, and transient keyword ensures that um, those fields will not get serialized. Okay, while doing the serialization, those fields will get ignored. So are there any questions on what we just discussed? Hello? No. Okay. So here in our class talk exchange, we are having two transient fields and one non-transient field. Okay, then we have a constructor to initialize these variables, a two-string method to print the values. Then we are having two more methods here, write object and read object. So first, what it does is it the write object is going to write invoke this default write object on your output stream. Okay, object output stream object. So default write object method ignores your transient fields. So it would only store the information for your ST price. And here you are specifically, or you can say explicitly storing the value of your this stock pin, ST pin. Okay. But while storing the value of your ST pin, you are making some changes to it. So you may think of it like that, okay, I'm also storing my password, but while storing my password, I'm making some changes in my password. So I'm making some arithmetic changes in it. Like for this example, I'm multiplying it with the 1000 so that if in case someone gets the data of the bytecode, or maybe if someone gets my hard disk, he will not be able to easily retrieve the information of the password because in a way I have encrypted the password. And then I have this read object method that can read the data from the object input stream. And here, while reading this integer information, I am explicitly dividing it by 100. Okay. So first I encrypted it, and this is a way to decrypt it again. That is, To encrypt it, I multiplied it by 100, and now when I'm decrypting it again, I'm dividing it by 100 so that I can get the original value, and the original value will be used to set the value for your ST pin. Okay, so here what we have done is we have created an file output stream, and we have passed this stock object, stock purchase object to the file output stream. So what it will do is it will only it will invoke the write object method first of all. Okay, and write object method will invoke the default write object method, which will only store the non-transient field, which is 500.75. So it will only store this information, 500.75. But in the next line, you are explicitly storing the information for your ST pin, which is you are explicitly storing it, but while storing it, you are multiplying it by 1000. So while being stored as a bytecode, it will get multiplied as 1000. But when you read this input file, but when you'll read this from the input object input stream, so the information that is stored in the bytecode will give you the value of your ST price as 500.75. But the value for your AAPL and the value for your 1, 2, 3, 4, 5, 6 will not be there. But since you have explicitly stored this ST pin, by multiplying it by 100, by multiplying it by 1000. So the value of the integer value that you have explicitly stored will be read over here, will get multiplied with 1000, that so that you get the original value of it, and would be used to initialize the value of your ST pin, or maybe to set the value for your ST pin. So overall, your 500.75, because it's a non-transient field, so will get stored by default and will get retrieved by default. And regarding this 1, 2, 3, 4, 5, 6, so we are explicitly storing it by encrypting it, and we are also explicitly uh, retrieving it while also decrypting it. Okay, but this information of AAPL will get lost because it was a transient field and we did not explicitly store it. So eventually what we will get our ST price equal to 500.75. ST symbol will become null because it's a string, and if nothing is present for the string, it's treated as null, and ST pin will be equal to 1, 2, 3, 4, 5, 6. So your output should be uh, this. Okay, are there any questions here?
Sir, here transient field is not additionally getting means stored. That's why we are setting it as null, right? ST symbol is null because already it was transient. But I have seen in one question this can also be handled by setting it once again, right?
Yeah, for example, for ST pin, we are explicitly setting it. You see,
ST
so
pin
if
we are
you
doing
do it
it.
explicitly, so that could happen.
Hmm.
Okay. So yes, moving on to the next question. Here we have a question regarding the file output stream. So here in the file output stream object, there is this second attribute which is set to be true or false. So why the second attribute is there? So if you see the second attribute here, will tell you that if the file is already present, then do you need to append or overwrite the file? So if it is set to be true, that then it means yes, you need to append the value to the uh, append the value that we have over here to the existing value. But if it is set to false, that means you need to overwrite the file. Overwrite the file means you doesn't matter what value or maybe what text was present in your file previously, you start writing from here only. Okay, so the second parameter tells you whether you need to append or not. So if it is set to true, that then it means you will append, and if it is set to false, then it means you will not append. So there is one more case here in the file output stream where the second attribute is not set. Okay, so by default, like if you just have a file name over here and if the file already exists, then in that case by default it is considered as false. That is, by default it will try to overwrite the file. But if you explicitly mention true over here, then it will not overwrite, rather it will append to the file. So for example, here in this question, both the file had hello friends written on it. So in this case, when we have true over here, that means this welcome to the party will get appended. And in file 1.txt, you will get hello friends, comma, welcome to the party exclamation mark. Okay, that is this guy. But in the second file, since the second attribute is set to be false, that means you will not append, rather you will overwrite. So overwrite will mean doesn't matter what value was already there in the file, you start from here only, comma, welcome to the party. So the second line, for the second file, the text is going to be comma, welcome to the party. But for the first file, the text is going to be hello friends, comma, welcome to the party, this option. Okay.
Sir,
So if
here,
no questions are there, we can move to the next line.
sir, this, okay, yes, this one, okay, this one, okay. But I have just one query. Why there is a comma, then welcome to the party? Why the first
Because
part?
it's there in the question itself.
Okay, okay.
Okay, then we have our next question. So here we are using this concept of lock and unlock. So here we are using this reinterent lock. So as we have seen that if we have multiple threads accessing the critical region is the region where we are reading or updating the values of the shared variable. So we can get ambiguous outputs in such cases, like happened in our first example. And we can get those race conditions. We call it race conditions. Now, to avoid those race conditions, we try to introduce this notion of mutual exclusion. And to achieve the mutual exclusion, we have some inbuilt methods, inbuilt ways in our programming language. So one of the ways to declare the method as synchronized. So if a method is synchronized, only one of the thread can enter the method at a time, while the other threads should wait. The other way is if we synchronize the object, and then we can introduce the notion of wait and notify. So we have these methods like wait and notify. So if I'm, let's invoke the wait method, that means all the other threads should wait, and then the notify method means if I'm done with my execution, so I can signal the threads which were sleeping, now you can get awakened, and maybe you can, one of you can try to uh, enter the critical area. So when we use the notify method, so we only awaken one of the sleeping threads, and when we say notify all, so we awaken all the sleeping threads, and then maybe the wait, then one of them um, enters the critical region and then calls the wait method, due to which all rest of the threads go to their sleeping state. Okay, coming back to this question, here we are using the locks to achieve the same thing. So what happens in a lock? So what we can do is, there is one more way of achieving the mutual exclusion, that is by using the locks. So what we do is, let's suppose there are four threads who want to enter this critical area. This is the critical area. Okay, and there are four threads, let's say T1, T2, T3, T4. All four of them wants to enter the critical region. So one of them will reach here first, right? Because in any case, one line gets executed at the time. So one will reach here first. So I'm assuming, let's say T2 reached here first. So if T2 reached here first, what will happen in this case? So T2 will invoke this lock method. Okay, so what happens in a lock, that rest of the three will go in their sleeping state. Okay, the rest of the three will go in their sleeping state or maybe in their waking state. So we have seen the states for the thread where we have this new state. So when you create a thread object, it is in its new state, and when you invoke the start method, so then it comes to its runnable state. Then you have this running state. sorry, it got muted for some reason. So you have your running state, and then when it is actually executing the part, then it is in its running state. And then you have your other states, like for waiting also you have a state, and if it's done with its execution, you have your states when your thread dies. Okay, so what happens when T2 acquires the lock? So we call this acquiring a lock. So let's say thread 2 enters here first. So thread 2 will acquire the lock. So what will happen to other three threads? Other three threads will go in their waiting states. Okay, so then thread 2 will acquire the lock and will uh, enter the critical region and will execute the code from the critical region. And the moment it executes the code, we have this unlock method in our finally block. Why it is present in the finally block? Because no matter what happens, even though there is some error, we want this thread to unlock. Why? Because unlocking means other threads can waken up. Okay, because we do not want the situation of deadlock. What's the situation of deadlock? Means threads keep waiting for each other to complete their task. Okay, so we don't want other threads to wait endlessly for this T2 to complete its task. That is why unlock method is there in your finally block, so that doesn't matter what happens, at least the other thread should get waken up from their sleeping state or from their waiting state. Okay, so let's say thread 2 acquires the lock. After acquiring the lock, all the other threads will go in their waiting state. It will execute the code from the waiting area, and then it will we use the unlock method. So unlock method means now it does not acquire the lock. Now other threads will wake up from their sleeping state. So other threads will come in their runnable state. Okay, now you'll have the same thing with T2, T1, T3, and T4. Now T1, T3, and T4 will try to acquire the lock and will try to enter the critical region. One of them will acquire the lock and the others two will again go to the sleeping state. So it's a recursive way of providing the mutual exclusion. Okay, this is why we used the logs. So just because we are having logs over here, this would ensure that the code that we have written over here in the try block will get executed only by one thread at a time. So what are the possible cases? So here we have this run method where it will invoke the buy method from this warehouse object by passing name and quantity, and this is the buy method of your warehouse object. So here we can see in the main method, we created a warehouse, we created two customers, and then we started the thread for both the customers. So what could be the possible output in this case? So again, here we are having two customers. So threads for these two customers. Again, you can see that there is this thread 1 T1 and then there is this thread 1 T2. And both threads are trying to acquire the lock. You're having your T1 here trying to acquire the lock. You're having your T2 here trying to acquire the lock. Okay. So what are the two possible cases? First possible case is T1 acquires first. Okay, and the second case is T2 acquires first. So the value of your stock initially is 5. Okay. If I write some details regarding T1, so T1's name is, I guess, Ram, and the second guy is having this name Ravi. It's 3 and this is 4. I just need to cross check it once again. Yeah, 3, 4. So here we are saying that T1 acquires first. So what will happen if the T1 acquires first? So T1 will check if the value of stock is greater than the quantity. Then you decrement the value from the quantity and you write Ram bought these many items. Okay, so here we see that 3 is less than 5. So what we are going to do is first we'll decrement the value of stock to 5 minus 3, that is 2. And then here we are going to print Ram um, maybe bought 3. Okay, so once RAM is done with its part, then it will unlock. Means if thread 1 is done with its part, it will unlock. And unlock would mean now thread 2 can go and acquire the lock. So thread 2 means Ravi. So
So you
Ravi,
haven't subtracted the value of a stock and the number.
sorry, could you repeat again, please?
Stock minus quantity is there, right? If a stock is
Yes.
greater than a stock quantity, then you have to subtract that value first, and then you have to print the output, and after that you will unlock. No?
Yes. So first you lock, then you check whether the quantity is less than stock or not. Then you update the value of your stock, then you print the statement, and then you unlock. So once you have unlocked, now thread 2 can acquire the lock. So when thread 2 will acquire the lock, now thread 2
It
will
will
check whether
again
the
check it.
quantity is less than stock or not. So quantity
Mhm.
is 4 and the current value of stock is 2. So which is incorrect. That means you will print the code inside the else statement, which will
Cannot
say
buy.
that Ravi cannot buy these many items. Ravi cannot buy 4 items. And here we have 3 items. Okay, so you'll get these two lines of output because only these two things are there in your print statement. Okay. On the other hand, if T2 acquires first, what will happen? First, you are going to print Ravi uh, bought 4 items, and then you are going to print Ram cannot buy 3 items because you will be only left with 1 item in your stock. Okay, so you can't buy 3 items. Okay, are there any questions? So only these two possibilities are there. So you can either get uh, Ram bought 3 and Ravi cannot buy 4, or you can get Ravi bought 3 but Ram cannot buy.
This
This
second
one is not
condition,
possible.
sir,
Yes.
this
Mhm.
second condition can only occur if we start from, means like the thread starts from the Ravi itself, not from the. There are two
Uh,
conditions, right? First condition is Ram bought 3 and Ravi cannot buy 4 items.
yeah.
And the another is Ravi bought 4 and Ram cannot buy 3 items. Now, if you go to the code, here we say T2 dot start first, right?
Mm.
And T2 is Ravi, I guess.
Hmm.
So that makes sense. But the first one is because because in thread we can't predict the order of execution, right?
Yeah. So see, even though you started the thread, okay, but
Hmm.
the start method that just means that you both the threads now are there in their runnable state. Now you don't know that which run will get executed first. Okay, though
Okay.
this thread got started first, but this also does not it did not take a lot of time to get started.
Hmm.
Okay, so here
Hmm.
you again don't know that what would be the sequence of your execution. Okay, same problem
Okay.
was there with the first guy itself, that you don't know that which uh, thread
First
will get
question will.
started first. This thread
Hmm.
can execute first, and then maybe you can come to this one, and then you can print total.
Understood.
Yes. 10th question. So here we are seeing that what print largest mammal. Okay. So you have an abstract class animal that has this method called size. You have mammal extends animal. You have this bird extends animal. Also, you have this animal size finder class. Here you are having a main method uh, that created a list of animals, and then you have your print largest mammal animals. And here you are seeing write a function header. Write a function header for a method print largest mammal that iterates through the list of animals and prints the largest mammal size. So what do you think? What can we write in our function header? So maybe first it's going to be a static method. So we can write public static, and then we can write the return type. So return type, because we are just going to print the value, so we can have return type as void,
and then we can write the name of the method. So the name of the method is print largest mammal. Print largest mammal that will take a list of animal maybe. Okay, let's call it a list, right? And then there would be some lines over here. This could be one of the function header for our print largest mammal function. The second possible header is when we use the generic. So we can have public static. Before the return type, we can mention that t extends animal, and then we can have our void print largest mammal, print largest mammal, and here we can have a list of t a list, and then maybe few lines over here. That is the second possibility, right? We also have one way of writing it using the wildcard. So we can write public static void and then name of the method print largest mammal. Here we can write list of anything that extends animal, anything which is a subtype of animal, and maybe a list, and then we can have other lists. So these three ways are possible. Okay. Now, if we check the options, the first one, yeah, it's fine. The second one is fine. The third one is not correct, just because the T is unidentified. Okay, your class does not know that what this T is. No, so this T needs to be specified before the return type, or at least your class should have this T over here. So at least it should know that what T is. And the fourth one, though it can accept a list of anything, so it should also be able to accept a list of animal from here. But because we are somehow going to invoke this size method while iterating over this list, so that is why we cannot use this one. Means if we use this function header, so we'll be able to accept this list of animals. There would be no problem in accepting the list of animals. But when we try to invoke the size method while iterating over the list, we'll get to know that we cannot invoke the size method just because the size method is not present in the class object. Okay. So if you want to invoke the size method needs to be, because size method will be present in the animal or the subtypes of animal. That is why extends animal needs to be written over there explicitly. That is why this option is incorrect. Okay. Are there any questions? Are there any questions, guys?
Not from
Okay, then maybe we can check out this one where we have return value link points to the start of previous activation record, which is incorrect. Control link is the one that points to the start of previous activation record. Second is an activation record is pushed into the stack when a function is called and is popped out when the function returns the value. Yeah, the second one is true, right? Are there any doubts or questions on it?
Sir, what
Third
does
one,
return value then do?
sorry, could you repeat again, please?
Return value link, what does it points to? Return type of
Return
the
value link. Return value link points to the location where the value needs to be returned. Okay, so for example,
return.
in my factorial of 4, there would be an n which maybe I have set as 4, and then maybe let's say I have created this s which is equal to factorial of 3. Okay, so because s is equal to factorial of 3 and my factorial of 4 is just 4 times this s which is equal to factorial of 3, so that would call factorial of 3 from here. and the factorial of 3 will also have its n, will also have its s, okay, which will again uh, have this factorial of 2, which will again have this factorial of 3. But let's suppose the factorial of 3 returned the value. Factorial of 3 returned maybe 6. Okay, so there would be a return value link over here, a return value link, and then there would be this control link. So control link would be pointing to the start of previous activation record so that it knows the context of what is going on. Okay, similarly, this return value link will point to where the value of factorial of 3 needs to be returned. So factorial of 3 needs to return its value here. Okay, so return value link points to the location where the value of function needs to be returned. Okay, whereas control link points to the start of previous activation record. Is it clear? Like, is it clear?
Yes, sir.
Okay, the
B and
second
D
one
will
is
be the answer.
yeah. Are you saying something?
No, I'm saying B and D, the last option should be the answer.
Yeah, let's see the Cth option. The Cth option says the variable present in activation record in stack are in scope and accessible. No, only the variables
The
present in the
topmost.
topmost activation records are accessible and are in the scope. And like you can see it very well. For example, for this factorial of 4, the value of n was 4, but for this factorial of 3, the value of n would be 3 here. Okay, and in the factorial of 3, when I'll say n, so I'll be referring to this 3, not this 4 over here. So the topmost activation record, which in this case is 3. Top means if I'm making my stack like this, so the activation record that was pushed in the last is going to be my top. Here I'll be having my top. That is whatever was pushed in the last, and whatever will be popped out first is going to be my activation record on the top. Okay, so the B and the D are the correct options, correct statements.
Okay.
Then we have few more questions. You have your vehicle.java in your pack 1, car.java in your pack 2. Let's quickly go through these questions. Test.java. So this test.java is present in pack 1, like it's in the same package as your vehicle.java. Okay, so here we are going to first invoke the speed method. Speed is public, so yes, it can be invoked. Then we are going to invoke this fuel method to check whether the fuel method is present in vehicle or not. So fuel method is there and the fuel method is protected. Okay, so that can also be used, because in any case car is a what, car is a subtype of vehicle. Okay, car class extends your vehicle class, and also your pack 1 and test.java are in the same package. And here also the capacity, but the capacity method is private, so it won't uh, the compiler will not allow you to compile the code, and the line 3 will throw the compilation error. So this is the correct option here.
So this question was in quiz too, right?
Means a similar question would be there. Means
Mm,
exactly this question was there or not, I'm not very sure
no,
about
no.
it.
Similar type of question was there.
Yeah, here you have your example class having this run method. uh, Example extends thread, it has this run method, it has this map attribute, and when you invoke the run method you just put this key value pair in your map, and the map that we have created here is going to be a linked hash map. So the order of insertion is going uh, to be the order when you try to print the map. And then you have your string, an array of string, an array of integer, which you are using to initialize this map. So it's basically your map would look like this if I tried. Your map will be like this. Your map is having this apple 1 and then banana 2 and then carrot 3. And so you have just created this map and now you say t dot start t dot join. So start would mean that you have started this run method in a parallel thread. Okay, you have started this run method in a parallel thread. What this run method will do is it will just put this key value pair again 4 in your map. Okay, but here you have also used this method called join. So what this join method is, join method means if you are using this join method in your main thread, it means your join method is going to wait for your this thread to complete its execution. Okay, so once the execution is completed, only then you move to the next line. So this thread that was started over here, this join method will say the main thread is going to wait for this thread to complete its execution and then only you will move to the next line. So that means
It's like
until or
for that
unless this
last.
egg and 4 get inserted in the map, you are just going to wait for it, and then you finally say you're going to iterate over this map and you're going to print the values of the map. So you're going to get something like this: apple is 1, banana is 2, carrot is 3, and egg is 4. So that should be your answer. Okay,
Sir, can
all
you just
this,
slow the that that okay, it was t dot start and t dot join, right?
yes, but there is a very similar questions in your practice assignments where they are not using this t dot join. So what happens if you do not use this method here? So what happens if you do not use this method over here? Okay, so if you do not use this method, that would mean that you are not waiting for this process to get completed. So then you have multiple possibilities. One such possibility is you're going to get this apple 1, banana 2, and carrot 3. That is, first you printed the values in your main thread, only then this execution of addition got completed. Okay, so that is one of the possibility. The second possibility is that this uh, process of putting got completed and then you executed the printing, so you got this as the output. The third output is also possible where you got this concurrent modification exception that you usually get if you're trying to iterate over an array and iterate over any iterable object, and then you see while you're iterating some changes happened over it through some different thread. So this could also be one of the possibility if you do not use this join method. Okay, is there any other possibility? No. That these three possibilities could be there if you do not use the join method. Okay, but since we are using the join method, there's only one possible output, which is this. And yes, where you are using the join method is also important, right? So before doing any of this, you are using the join. Then the next two question, this next question is easy. Here it says displaying t, displaying u. What will be the output? So you see, it's just public void display t value, public void display t value. So both these methods are same. So you're going to get uh, a compilation error in line 1 that says this display method is already defined. Why?
Sir, this
Because
P and U are not bound, so they will return an object, right? It can be of any type. Means it can be of any object T and it can be any object U. So basically, they are both the same method itself, right?
yeah, so it's all comes down to how your compiler sees these lines. So your compiler do not see these generics. Your compiler is going to read it as the same thing we could have talked over here, that your compiler does not see this as public static t extends animal and println blah blah blah. Your compiler sees this as public static void println a list of animal. It tries to generalize it as much as it can. Okay, so since you have specifically mentioned that T is going to be an animal or subtype of animal, so it assumes that it could be a list of animals, or compiler is going to see it as list of animals. Same happens here also. It will also see it as a list of animal object. So basically, whether you write this or this, your compiler is going to see this as the line one only. Okay, and same goes with here, this question also. Your compiler is going to see it as both the methods will be like this: public void, and then there is this method name display, and then T. So you have not specified any condition on T, that T is a subtype of any class. So it will take the most generalized case, which is object, and then maybe. Okay, so your compiler will read the line as this, and the second line also looks like this. So it's not overloading because both the signatures, everything is same. So your compiler is going to throw the error at this line. We'll say that this is already present. We're going to do it again. Okay, are there any other questions? Sorry, are there any questions for this? No? We'll move to the next one then. Here you are having this executive class, a director class, uh, a copy constructor for the director, a class called corporation where you have defined this executive, uh, where you have defined this d1 and d2, and then you are setting the value of d2 as Rajesh, and then you're going to see that what's going to be the value of what will get printed in this case. So again, you can make the diagrams and you can see how it will get printed. So first, if you print Anjali, first if you see d1, how d1 will get created. So director Anjali, director object has this name and this project count, right? So it will have this Anjali and 5. Let's say this box it has. So this is this Anjali, and then it is equal to 5. This is your d1. Okay, then d2 is just, you have used a copy constructor. So your n is going to refer to this Anjali, and p is going to be a duplicate of 5. And then you say you are going to change the name for this d. So your d2 dot name is going to be Rajesh now. So d2 dot name you can change to Rajesh. So you say that this reference is no longer there, rather this n points to Rajesh. And when you try to print d1 and d2, so this will get printed because the actual object type is still director. So there is two string method in executive also, there's two string method in director also, but since the actual object type is director, the two string from the director will get printed, and you're going to get this name equal to name comma project equal to this. So for the first guy it's going to be name equal to Anjali and project equal to 5, and the second guy it's going to be name equal to Rajesh and the project count is going to be 5. For question number 16, hey, are there any questions? If there are any, just let me know. Okay, for the 16th question, if we see, there is this connectable interface where we have this abstract method. The earbuds implements this, which is again an abstract class, and it introduces one more abstract method, play music. So this earbuds is getting implemented by both airports. This earbuds is getting extended by both these airports and this Galaxy Buds class. Here we see we have defined the implementations of both connect and play music. Both connect and play music is implemented in both the classes. And then you have your class user. Here we say that public static void show details earbuds object obj.connect obj.play music. So in the next line we are saying that the show details method is going to accept an instance of class earbud or any subtype of class earbud, and it's going to invoke these two methods. So you'll check whether the connect method and play music method is present in earbuds or not. So play music is present in earbuds, and connect is present in its uh, connectable interface which is being implemented by the earbud. So yeah, no compilation error over here as well. And now you're going to implement the show, invoke the show details method by passing the new AirPods and Galaxy Buds. What would be the output? AirPods connected, AirPods playing music, G-Buds connected, G-Buds playing music. Pretty easy one.
Which
Any questions? Any questions?
No.
There are no questions. We are moving to the next question. Here, it says you use this iterate method. So what iterate method will do, it will start from this initial value and it will keep generating the values by using this function. So it's like you take the previous value and you multiply it with 2. So it's like you start with 1, you multiply it with 2, so the next value is 2. Then you take the latest value, which is 2, and you multiply it with 2 again, so it will become 4. So like you'll be having
so
your values is 1,
how you
2,
identified
4,
that?
8, 16. Identify what?
This that it will take the previous value and multiply it.
Here also it's given, and if you see this iterate, you'll get to know this iterate method how it works. And here also they have given the functioning of
I
this
got
iterate.
confused with this e comma f of e then f of e.
So it says e is an initial value and f is a function over here. So first is going to be e, that is 1 over here. This is your e. Second is your f of e. F of e basically means you put f in e in your function. Your function is what? So your f of x is x times 2. Okay, so f of e, which is 2, is going to be 2 times 2, which is 1 times 2 equal to 2. Okay, then it's f of e, and it means f of e is this guy, right? So you put f of this guy 2, which is 2 times 2, which is 4. So this is the next thing, and so on.
Okay.
Okay, so it will keep generating the values, and then there is this map also that will add 1 to every value. So it's like it will become 2, 3, 5, 9, 17, and so on. And then it says filter out the values having which are divisible by 3. So this is not divisible by 3, this is not divisible by 3, this is not yeah, this is divisible by 3, this is not divisible by 3. Okay, and so on. And then you say you limit it to 3, like you only need to have 3 such values. So one value is 3, the second one is 9. Maybe if we go in the sequence, we'll get 32 here, 33. Yeah. 33 is divisible by 3. So that is going to be the next thing. And then it's just for each value, you are going to print the value like this. So it's going to be 3, 9, 33, maybe this. Are there any questions? No?
No, sir.
In the chats, do we have any question? No? Okay. Yes. So here we move to the next question where we have a room service interface
So,
having this room service method. Yeah.
so where can I find this recording for this class? Because it's not updated in the calendar, right?
Calendar.
Yeah, the TA session is not updated for today, right?
Actually, this is not a TA session per se. It is more conducted by the Gear House for
Oh, I
the
see.
basically the students of Gear House, and
Okay.
you can find the recording if you want on the YouTube channel of Gear House itself.
Okay. Thank you. Thank you so much.
Yes, so the recordings will be updated by tonight itself, I guess. And the same set was discussed in the previous TA session also. So in the calendar, you will find, just check out the recordings of yesterday's TA session. You'll get it. Okay, so yeah. we have this class hotel. Here we have few of the methods. A method to generate an instance of standard room, to generate an instance of this deluxe room. uh, Both standard room and deluxe room are private inner classes, and both implement this room service. We know one of the applications of interface was that because we cannot reference, or maybe we cannot create an instance of this we basically we can't reference these private inner classes objects outside the um, wrapping class. So maybe so the clever solution that we came up with was to use the interfaces where the private inner classes can implement the interface, and outside the class, outside the wrapping class, if we want to use the instances of those classes, we can use these interfaces to refer to those objects. We'll see the example in the same question itself. Here the request service uh, method is defined. So here we have created a new hotel object, and we need to create obj1 and obj2, and in those obj1 and obj2 we need to invoke this request service method. And what should we get? The output should be a room service is available for additional charge. That is, the obj1 should be an instance of this standard room, and the obj2 should be an instance of this deluxe room. So how should I create obj1 and obj2? Because I know that I can't do something like this, that standard room what is it, c1, obj1, sorry, obj1 is equal to new standard room. This is something which I can't do. Standard room, blah blah blah. Right, why I can't do it? Because standard room is a private inner class, and private inner class is not accessible outside its wrapping classes, which is hotel in this case. So I can't directly create the instance of standard room. So let's try to divide this problem into two steps. First step is to create an instance of standard room. So to create an instance of standard room, we have these methods here. So if we use get room service one method, it is going to create an instance of standard room. But this get room service method needs to be invoked on an object of class hotel. So we should have an object of class hotel. Do we have it? Yes, we have it here. So we can do h dot get, what was it? Get room service one, get room service one, and that would create an instance of this standard room for us. So one problem we have solved, but still we are left with the another problem. That is, I am defining this obj1 variable, but because Java is statically typed, so I should also mention the type of this obj1. And I cannot mention standard room as the type because standard room is not known by this main class or this hotel test class. So what can I do? So that is why interfaces come into the picture, because I can't refer this obj1 as a instance of standard room directly, but I can use this room service as the um, what reference type for this obj1, right? This because the standard room implements the room service, so room service can be the reference type. So is it clear? The same thing I can do for the second guy also. I can do room service obj1, obj2, which is h dot get room service 2 this time, because the second guy is the deluxe room, and the deluxe room object can be generated by using this get room service 2 method. And again, you might think that why we are not referring it as standard room, because again standard room is not known by this hotel test class, so we can't refer it as deluxe room, we can't refer it as standard room. But because standard room implements the room service, we can refer it as room service. Any questions? So the two lines that we were looking for should be this. Any questions?
So here we are using interface to access the uh, get room service, and means like basically uh, accessing the private class methods, right?
Yeah. To we are not using this interface to access the private inner classes. We are just using the interface to refer the instances of these private inner classes.
So how does it know which one to print based on this get room service 1 and get room service 2?
See. That is why your dynamic dispatch comes into the picture. So first, it will check request service method is present in this room service or not. So you'll go to room service, you'll see request service is present or not. Yes, it is present. The next step is while executing, it will check the actual object type for this guy obj1. And what's the actual object type? Actual object type can be known by using this get room service one method. So here we have this get room service one method that is giving us a new instance of standard room, and the actual object type is standard room. So from standard room, this request service method can be invoked.
Okay,
Okay,
sir.
so we just need to pass the compilation. Once we have passed the compilation, during the execution, the dynamic dispatch will do the work for us.
Okay.
Okay. Then we have the next question where we have this off nullable method. So in optional, we have seen many methods. One of the method was off, optional dot off. So what that off method does, off method will just wrap your value in a box. Option. What we knew about the optional was it's like a box. So this box will either contain a value or will not contain a value, right? So why we preferred optional? Because we do not want the null value to be returned, because it can potentially cause the null pointer exception. So what we did was, this value can be wrapped inside a box. So if the value is not null, then we can put that inside this box. But in case the value is null, so we will pass this empty box. So optional is like a box. So the box can either contain a value which is not null, or it will be an empty box. Okay, that is what we do. So this off nullable method, why it is used? So if I just do off a value, so doesn't matter what the value is, it will just put that inside the box. Okay, so what happens if the value is equal to null? So it will just put null inside the box. So why we use the concept of optional? Because we wanted to avoid this null that can potentially cause the null pointer exception. And if we can directly put the null inside the box, so then it will just, the whole efforts of defining the optional will go eh, in the vain, because we wanted to avoid this null and now we are putting the null inside the same wrap. So then this method called off nullable comes into the picture. What this off nullable method will do is, off nullable method will ensure that if the value is not null, then you put that into the box. But if the value is equal to null, then you return the empty box. Is it fine? So that is why you use this off nullable method. Is it fine? Yes, no,
Yes,
guys.
sir.
Okay. So here we have created an array list. In array list, we have added two vehicle instances. One is Tesla having the type as electric, and the second is Toyota having the fuel type as null. So here, what we are doing is we are creating an option. We are iterating over this list of vehicles, and we are wrapping the fuel type in this in this optional box. So what this off nullable will ensure is, if the value is not null, then the value will be wrapped in a box, and if the value is null, then we are going to get an empty optional, or you can say an empty box. Okay. Uh, so what happens first? First, you have Tesla having the fuel type is electric. So fuel type is not null. So in the box, you will be having this fuel type, which is electric. Okay, then you have this if present method. So what this if present method will do? So this if present method, if your box contains a value, then your if present method will have some consumer function, that is a function that can do something with this value. Okay, so if your box contains a value, so your if present will pass the value to the consumer function, and then whatever will be the output, you will get it. Okay, but if your box is empty, if your box does not contain anything, then if present will ignore it. Okay, so your if present does two things. If it contains a value, pass the value to the consumer function. If the box is empty, then ignore it. Move to the next line. So here the box is not empty this time. So if present, will just pass it to the consumer function. What the consumer function is doing, consumer function is just going to print the value. So the first line of your output is going to be electric. Then you move to the next iteration where you have this uh, Toyota having the fuel type is null. So since the fuel type is null, and what this off nullable will ensure is if the value is null, then it will just create an empty box. So since it is an empty box, what if present method will do? If present method is just going to ignore this box and will move to the next iteration, and there's no next iteration. So there's only one line of your output which is electric. Are there any questions?
So means because it is of type optional and it is null, that's why it will be ignored.
If it is an empty optional, then it will be ignored.
Okay.
Empty optional. See, optional containing null and empty optional both are different things. Okay, empty optional is like an empty box, and optional containing null means a box that has null inside. And this optional off nullable will ensure that you will not reach the situation where you have this null inside a box. This summarizing int, what this summarizing int function will do, it will create an instance of int summary statistics. Okay, so here what this int summary statistics will do is, int summary statistics contains a lot of contains the summary statistics uh, for a data, which includes the count, minimum, maximum, sum, and average of the data. So here what we have done is we have created an array list where we have numbers from all the even numbers from 10 to 20, including all even numbers from 2 to 20, including both 2 and 20. Okay, so what we are doing is we are uh, taking each and every number and we are passing each and every number to the summarizing int function. So basically it's this int summary statistics object that we have created. Okay, we'll create the summary statistics for the number from statistics for the numbers from 2, 4, 6, 8 till 20. Okay, so it will have the count. Count is going to be 10, I guess. 2, 4, 8. Yeah, count is going to be 10. Your minimum is going to be 2. Your maximum is going to be 20. Your total is total no sum, I guess. Your sum is going to be, if you take the sum, so it's just take 2 common, it's just 1 to 10, right? So 1 to 10 is 55, I guess. So 2 times 55, which is 110. So sum is 110, and then you have your average. So average is again 110 divided by 10. So it's this.
Returns
Okay,
double.
so sorry.
Average returns double.
Yeah. So you are going to get what? First it's printing average, then it's printing sum, that is 110, then it's printing max, then it's
Okay.
printing min. This is what you're get. Okay. Moving to the next question, here you have an array list and a linked list and array list. Uh, LL refers to your linked list first, then AL refers to this array list. In AL you added 1, and AL you added 2, and then you have your LL referring to AL, and then you say AL dot remove 1. So let's see how this will look. So this is my AL, this is my LL. So initially AL refers to an array list which has these two values, maybe 1 and 2. Okay, and then so on. So 1 and 2 are there. Okay, this is index 1, index 2, or index 0, index 1. And your LL will refer to some linked list. Okay, what happened then? Then you did LL is equal to AL. This means now LL also refers to this guy from over here. That is, you'll remove this reference and you'll add this reference. This refers to this. So this will get deleted from the memory. Okay. But while doing it, you must ensure that your LL variable should be of type that can refer to this array list. So here we are safe because LL is of type list of string. So list of string can refer to an array list also. So we are safe. Okay. And then it says al dot remove one. So in list you do not have any method like this where you can remove an element from a particular index. Okay, but in your array list you do have these methods where you can remove an element from a particular index. Okay, in list you have this method of remove and you put element, so the element gets removed. But in array list you have this remove. In addition to that, you have this method remove index where you specify the index and the element from that particular index gets removed. So this guy will get removed because it is at index number 1. So when you try to print the value of LL or AL, in both of the cases you will get this ON. Okay, so even if you print LL or AL, in both of the cases you are going to get this because both refers to just this object over here. Any questions? Yes, no? Guys, any questions?
So previous question.
Okay, the next question here is you have class vehicle, engine, car extending both vehicle and engine, which is wrong. Okay, so the question is to identify the error. Okay, this is final, this is final. First error is this line 11 where you cannot extend multiple classes at a time. Line 11 has an error. Then the next line where you are redefining this break, you're overriding this break method. But since the method is final, you can't override it. Final method cannot be overridden. Then you have your uh, okay, and then you have your line 18 and 19. So in your line 18, what you are doing is you're trying to refer an object of class vehicle by this variable of type car. So variable of type car cannot refer to an instance of class vehicle because let's suppose your car extends vehicle. In that case also your car is a subtype of vehicle. So vehicle can refer to car but car cannot refer to vehicle. So line 18 is wrong, and by the same logic line 19 is wrong as well. So 18, 19 both are wrong. Are there any questions?
No, sir.
Next question
This
says
question.
that, yeah, you were saying something.
Yes, yes. I was saying, yeah, that question, that J panel and all those.
Okay, can
This
we start
question.
with this?
Yeah, yeah, yeah.
No, I sorry if you were saying something I didn't get it. Could you repeat again, please?
No, no. I am saying that yes, you start that question. I have that doubt in that question.
Okay, so what this question does? We have java.awt, we are importing different classes from this uh, these packages. Here, see what happens is just a second. We can have buttons, we can have labels. Okay, we can have buttons and labels, and to group these buttons and labels, we group them in a panel. Okay, so let's say this is my button, this is my button. String, we will be talking about the UI components. Okay, now to group these buttons, I can use a panel. But again, nothing will be visible to the user because if I want something to be visible to the user, that needs to be presented in a frame because frame is something that will be visible to the user. Even though I define the button and if I define the functioning of the buttons as well, that on clicking the button, this should happen. If I'll not put the entire thing in a frame, it won't be visible to the user. So it would be there, but it can't be accessed by the user if it is not in a frame. So everything needs to be enclosed in a frame. Okay. So this is the basic of our swing. So here what we are doing is this button demo class is going to extend the J frame. Okay, so uh, the classes for frame, the classes for panel, even the classes for the buttons. In swings, it just starts with this capital J. Okay, so you have capital J frame to define the frame now. So for capital J button for defining the buttons. Now label is something if you want some text to be displayed, so that can come in your label. And then you have panel. So then comes this constructor for the button demo. So the moment you create an instance of button demo, two panels will be created. And now here we are creating two buttons and a label. So we are creating this button play. So whatever we pass here as an argument, this is something which will be displayed on the button. Okay, so there would be a button on which this play will be displayed, and then there would be a button on which this pause will be displayed. And on this label, click a button will be displayed. Okay, now we say this play button, pause button, both button we are adding in our first panel, and this second button we are adding in the uh, second panel. Sorry, what I'm saying. I'm saying this label we are adding in the second panel, and both the buttons we are adding in the first panel. And we say in our frame, this P1 needs to be added in the center, and P2 needs to be added in the south. South means the lower direction. So let's see how our frame would look like. So our frame would look like this. These buttons are there by default. These minimizing the stream, maximizing the stream. Okay, and then we have a panel in the center. So panel will not be visible to the user. It's just like two buttons, one having play written on it and one having pause written on it will be visible. And similarly, there would be one label in a different panel. So I'm going to draw some invisible boundaries for the panel. Let's say this is my panel 1, and here I'd be having my panel 2, which would have my label. Okay, and this label will be visible. So in the label, I'm having a text. Click a button. Maybe. Yeah, click a button. I hope it's clear till here. Now, we're going to do this. It's set action command. Set action command. So what this set
So,
action command does. So
and
again,
this center and south, what it does,
center south, it's like in where your panel needs to be added in the frame. So,
means how it looks.
so if this is your frame, okay, this region is what we call the north. This region is going to be center. This region is going to be your uh, west. This is going to be your east. This is going to be your south.
So we define the position using this.
Yeah, so it's just a naive way of doing it. Okay, so in swings we have because in swing we can just do a surface level UI UX. That is why this center, northwest, east, these things are predefined. You just need to mention. Okay, so if you want your buttons in the center, you just write center and the buttons will be there in the center. Whereas this panel 2 will get situated in the south, means the lower side. So initially it would look something like this.
Okay.
Okay. I hope it's fine. Is it? Shall we move to the next line? Guys, hello.
Yes, sir.
Okay. Moving on to the next line, we have this set action command method. So, what is this set action command method? So, we'll see two things. Whenever we perform an action, an instance of action event gets created. Okay. An instance of action event gets created. For example, I click a button, so an instance of action event will get created. S- Now I want, from this action event object, I want to retrieve the information regarding from where this action event is coming, right? Because in the backend I should know that from where this action event is coming. Based on that, I will perform the execution from my backend, right? So if this action event is coming from the play button, maybe I need to execute some different thing. If it is coming from the pause button, maybe I need to execute something else, right? So how to get the source of this action event, that remains a concern for us. So for that we have these two methods. One method is, we have this get source method. So get source method gives us the reference of the source. Okay, so if let's say this action event is coming from the play button, and if I say this play button is definitely going to be some button object, right? So where here I define this button object, so I define this button object over here, right? Button play. So it would be some object. Okay, so the object would be there somewhere in the memory, but it get source will give me the reference of the object, this play button object. Okay, so one method is by using this get source, and maybe then I can have my conditional checks, that if the source is coming from this play button, then you execute this. If the source is coming from the pause button, you do this. So how would you check? You can just check equal to. So equal to is used to check the reference, correct? So you can check equal to button play, because button play also, this variable also refers to the same memory location. And then maybe here you can check for button pause. If it is button pause, you do this. If it is button play, you do this. If this is button play, you do this. Are there any questions? Yes, no?
No, sir.
The second way is, for each action event. Okay, the second way is, for each action event, we can set an action command. Like, we can set an attribute action command, which is going to be a string. Okay, for each action event, I can set a action command. So for, let's say, whenever someone click the play button, for play button, I'm setting the action command as hello. For pause button, I'm setting the action command as hi. Okay, so from this action event, I can get the action command, get action command, and then I can do the string matching. That is, I can say that if it is equals to hello, this string hello, then means I would know that will it is coming from this play. So I'll do the execution for the play, and if it is equal to high, then I know that it's coming from the high. So it's coming from the pause button, so I'll do the execution from the high method. Okay, but we know using hello and hi does not make any sense, because it won't provide any solid information for the programmer. Okay, though even if you pass hello and hi, it will logic will work correctly, but for the programmer, for the point of view of the programmer, he's reading the code, he should also understand that from where it is coming. So for the purpose of just reading, we can just put play for the play button and pause for the pause button, but there is no such compulsion that you need to use the same strings. Even if you use some other string, it will work. Okay, and then maybe you can check whether it is equal to play, you do this. If it is equal to pause, you do something like
But it should be defined in the method itself that yes, this particular value is there. Means like equals method should be true there, right?
that. Yeah. So this get action command will give you the action command that we have set, right? So that means here, while defining the object, we also need to set the action command, and that is what we are doing over here. Set the action command. Set the action command. Okay. This is what we are doing in these two methods. For the play button, we are setting the action command as this string play, and for the second guy pause button, we are setting the action command as pause pause. Okay, are there any questions? Yes, no. Is it clear till here?
Yes, sir.
Okay, but then we also need to add the action listener. Action listener means if the action happens, there should be something to catch that action, that yes, the action happens. Okay, so usually what we do is the most common approach is to pass the same frame, the same object, the same frame object as the action listener. So here for both play button and a pause button, we'll just pass the same object as the action listener, so that adding action listener is the process when we actually add the functionality. That is, now if you press the button, some action event will be generated. Okay, then for the frame we can set the size, that these are the dimensions for the frame: 300 times 150. You can see it's going to be some rectangular object, and then you can set the visibility to true. Okay, so here we can see the width is 300, the height is 150, and then maybe uh, we have to see this action performed. So in the action performed, we are just going to see the check this logic. Okay, we are just going to write this logic. So select the code segment given below to be filled in action performed, such that on clicking the play button, the text label changes to playing content, and on clicking the pause button, the text label changes to content paused. Okay. So you see, on clicking the play button, this text should be displayed, and on clicking the pause button, this text should be displayed. So basically we need to change the text inside our label. So click a button was the text inside our label. If the play button is clicked, then the text inside the label needs to be changed to playing content, and if the pause button is clicked, the content needs to be changed to content paused. Okay, so let's see how it will look. So in the first case, what we are doing, we are using the approach of source. So we are using this method. So get source. If the source is coming from the button play, what you will do, you will say label dot set text, means set the text of label as uh, playing content. Else if the source is equal to button pause, then what you do, you just change the label to, that is label dot set text to content paused. Okay, so this one is correct. The second one uses this approach of using the get action command. So get action command will return you a string that is going to be play or pause. So you check if the string is equal to play, then you are going to play the content. If the string is equal to pause, then you are going to set the label as content pause. This is also correct. Third one, here you see it does not checks it with a string. It just checks with the play and pause, and it is going to throw the compilation error because it won't recognize that what this play and pause is. There are no variables having these two names. So this is incorrect. The fourth one says dot equals. That is fine. Get source equals. But here you should pass the reference of the object. Now these two strings are not the reference of the object. The reference of the object is this button play and button pause. Okay, so this is also incorrect. So are there any doubts in this question? Yes, no?
Sir, just in case those play and pause button are actually objects just like button, then that would work, right?
Uh, you were talking about this play and pause.
Yes.
Yeah, you'll have to see. It should be some string. Okay, means if you set it like play equal play equal to this string play, then it would work.
That's what I'm asking.
Yeah. Okay, and moving to the last question, it's very simple. The first one, the compiler will read it as public void sort array of sort array, and here it is going to be an array of comparable and obj. And for the second one, it's going to be an object of array, an array of objects. Sorry. I guess yeah, this one. Okay, you can check the answers and it's fine. Okay, so if there are any questions, you can ask. Else, we'll wrap up the session.
Sir, I was doing a PYQ today, and I had few questions in them.
Okay, let's do one thing. I'll close the recording and then you can ask the questions. Okay.
Okay. So means from the same portal I was doing